Well, here we are at our 12th and final session, where our speakers are taking us into the future.
Hey.
Please
Thank you.
welcome Nikki Parmar
Likewise, you too.
and Ashish
Sorry I couldn't be here.
Vaswani, the co-founders of Essential AI, and Ganesh Bell of Insight Partners, as they step onto the stage for our final fireside chat, What's Around the Corner? This power trio will share predictions and insights gleaned from research about the revolutionary power of AI.
Hello, everyone. How's everyone doing? All right, great. So, I'm just a prompt engineer for the afternoon, but you're carbon-based life forms, so let's get to know you first. Tell us your simple human story. Where were you born? How did you end up in research?
Hi, everyone. My name is Nikki Parmar. I was born in India in a city called Pune, and I found myself doing research and impacting on research through Google, actually. It started at USC, where Ashish and I actually first met, and it was when I came to Google, I got to see, the power of deep learning for products like search, and then made my way into research and started my collaboration with Ashish.
Hi, everyone. I'm Ashish. I was born in India. Spent the first 15 years of my life in the Middle East, and I'm going to fast forward to the first moment when I knew that I needed to get a PhD is when I I was studying logic, studying this famous proof called Gödel's incompleteness, and the first words that the professor utters when he enters class is, "What is truth?" And to me, I thought the PhD was the one route to it. Started my PhD in language. I was more excited about, we used to call AI machine learning then, by the way. Someday maybe we'll still call it, we might get back to it. But it was whether I sort of embed myself in this domain specificity of language or I invest in general techniques, and I invested in deep learning very early on. And Nikki and I met when I was a guest lecturer on neural network language models in her class. Then yeah, joined Brain again, and similar. Google Brain was one of the most important places for pushing AI research, and then again try to do something different, work on something new. So that's been my research journey.
It's great. So we have a lot of founders in the audience and online, and founders. I'm an ex-founder and operator, now turned investor. So we're really, really interested in founding stories.
Now turned prompt engineer.
Yeah, now turned prompt engineer. That's true. So I want to go back to the founding moment. It's funny that we've hung out so many times, and I've spent a lot of time. I never asked you this. Let's go back to the founding moment of the transformer model, right? I want to ask two parts. One is, as co-creators of electricity or fire of AI, right? Did you actually realize it? Maybe Ashish, for you, talk about the founding moment of leading up to it. Did you know you were actually working on something important? And when did you actually recognize this? And Nikki, for you, could you imagine the impact and how, it's been 6 years since you guys created the transformer, and did you actually foresee it?
Yep. Well, it's like a time long ago at a place far, far away. But so at the time, it's important to understand what was popular at the time, or LSTMs, which were basically processing text sequentially, one word at a time. So they both read text and they produced text one at a time, and that sucked because if you knew that it was going to be, if it was going to be a popular model, then everybody would be stuck with the sequentiality. So we started working on the transformer because we were very ambitious. We wanted to both read text all at once, all the words at once, which is what transformer does, but we also wanted to produce all the words at once too. So it's almost like instead of having things at time, we were trying to do it like this, where each layer would produce some words and fix them. We were not able to solve it. We've not been able to quite solve this sort of parallel generation as yet. But then because we were working on a fundamental problem, we knew we were also working on an extremely general architecture, and that's what excited me a lot. There were a couple of moments on the way, and it's funny that all those moments are kind of smushed together in a short span of time because we kept working. We made modifications because the first attempt at this parallel thing didn't work. We switched to actually changing the architecture to the standard encoder decoder, added best practices, and of course the team grew, and then we added some important changes. And then within a month, we started seeing results. Okay, boom, here's a result that's actually outperforming an existing result that combines a bunch of models. All right, next week, boom, another result. Then after that, okay, now we can also do parsing instead of just machine translation. So when these things happen in sort of quick succession, and you're actually seeing not just one task, but multiple tasks in multiple languages. And then, of course, you see that the architecture is leveraging physics because it actually runs well on modern hardware, and it's also learning very effectively from data. So then we knew that this is a very, very powerful general system that we had learned.
Yeah, and to continue off like where Ashish left off, like it was because of this belief, we pushed the transformer in not just like language and parsing and translation, but also in doing some early scaling work on pushing them on images, on speech, on text, on biology, because of our general belief that this would be a general substrate, a general fundamental block that could really apply to any task, any modality, given you have enough data and compute. But definitely, like what's been surprising and something I didn't predict myself was like how quickly people were going to adopt it or react to it. I think this kind of new interface that we have with chat to such a powerful technology and the quick adoption of it and like the ways in which people are pushing it forward was definitely extremely surprising, and it's also inspiring at the same time because now we can all collectively do a lot more.
So let's talk about that, the rate of innovation, right? Every time there is a new big architectural shift or a stack that emerges, some sedimentation of the layers happen, right? And in 12 months, we have, 50+ large language models. We count like 1 billion parameters and more. We have new frameworks. We have agent architectures, RAG, RL, AIF, human feedback loops, and different kind of tuning mechanisms, and so many layers that are kind of emerging. It feels like it's sedimenting faster, but yet at the same time, it feels like it's always shifting. Where are we today? Should we stop building and wait?
Never stop building, especially because all of us are kind of heading in one important direction of building this. A good analogy is that exists is that I like to think of it as we're building this intelligent operating system that's basically taking our goals and just converting it into actions and doing things for us, right? And where we are right now is we're kind of building the kernel, right? And we still haven't quite settled on it. And many of the things that you actually mentioned, the interesting bit here is that some of these are actually applications on top of the kernel, like or like how do you actually
file systems?
Yeah, exactly, right.
Yeah.
And then some of them have to do with the base capabilities of the kernel themselves. For example, RLHF, RLAIF, right. So I'd say that some things are probably we've landed on some techniques that will actually get us better and better models. The kernel is going to change, but I do think that if people work even on top of these shifting kernels, we'll actually get to potential standardization. Here's how you program these models to these end tasks. And then there's of course many other things that like maybe here's how you should communicate between models as an example, right? So I think that the kernels there's some techniques that we've converged on that'll help us build better kernels, and how we program these models is going to change, but it's essential that we actually continue to program them and automate our workflows so that we learn more and the process actually feeds back into itself.
Like, yeah, actually, it's like a system, right?
Exactly.
It started with the model and with the transformer, but it's really everything about from the data, from the human feedback. And even though it might feel like shifting sands, I think the assumption that the model in and by itself is going to be enough, and what we have today is it's a good starting point, but it's not a solution in itself. And so I think our effort and what we also believe in our company is in being able to build this whole engine or this system together, this operating system.
So if the kernel is still being built, what does the next level come from? Is this a new is it data? Is it new physics, new processes, or is it new representation of knowledge?
Yeah, it's interesting that.
Or is Transformer 2.0?
Exactly, right. So yeah, and you had to ask this. Yeah, I mean. I think the biggest crisis that we're facing in AI right now is that everybody's extremely excited about it in a very similar way, and everybody at one point, and everybody's converging on this one.
So it's like everybody's going to Burning Man.
Yeah, it's like the Burning Man of AI. Yeah, and I guess that also goes to I guess that also means that there'll be a lot of people in the Bay Area that are working on it. But so it's important. Every scientific revolution has required changing, going against the grain. I mean, all of the I guess all of the dimensions that you mentioned require innovation, but I do think that, well, I'm curious what Nikki thinks. I think that we will need it. Like maybe the future belongs to, for Transformer 2.0, maybe the future belongs to some graduate student that's actually thinking differently than what everybody else is thinking right now. Yeah.
Anything to add, Nikki?
I agree, because I feel that what is happening today is there's so much innovation, and taking what we already have and seeing, can we even create value out of it? And in this short term, we do have, you're right that the role of data is probably more important today than scale. The role of how do you build vertically integrated systems with the right interfaces that are able to take the user intent, what the user really wants to get to, the goal that they want to get to, and being able to put that into the model itself. Because even today, these systems are atomic, where the user has to do the work to to get the context, to guide the model to get to the answer. But we'll see a shift in that, where the model itself guides the user while having an innate understanding of the goals itself. So there's a lot more to be done, and I think it's going to come through these multiple axes. And but at the same time, for just completely new radical ideas, yeah, I think what she said makes it will come from where the places where we're not looking, which is how originally the transformer also happened.
So small versus super large versus this idea of specialized domain-centric models. What are your thoughts? What wins? Or is there a role for specialized models? Or is everything leading to the same ocean?
Yes.
We're all all rivers just heading to the same ocean. Yeah. Yeah. Oh.
That's it, huh?
Well, definitely. So again, this connects back to the previous question about there is very important things to be done in the short term that will feed into what we how these models evolve or in the long term. Right? Data is one of them. And so I think just access to data is currently, data is locked within pockets today. So specialized models that have access to this data that are actually that are essentially observing workflows or how people are working, and then eventually we use these models to automate these workflows. These kinds of domain-specific models will prosper. In the long run, Rich Sutton has this. Not a quote. It's sort of this lesson that we've learned in AI. He calls it the bitter lesson, that says general methods that leverage scale, data, and compute are going to win in the long run. I do think that to some extent, they will be, even for domains, we will benefit from generality models that actually learn and pick information across different applications of the same model in different domains and learn from feedback. That's so where does the generality stop, and you need one general model per domain, or you have one model that just rules us all? The latter seems harder. I do think that there is virtue to generality. We've seen it with the transformer and all what's coming out. Yeah.
Yeah, and just to continue on, one of the reasons is that till now, we've built models based on what people have said on the web, but to where we want to put them, there's still a gap, and this is another place. In a way, there's still a gap remaining in being able to deeply understand what we want to do out of it, the task definition itself, which is where there's opportunity for us and everyone here in the room, and it's going to be important to kind of take that either through the interaction with the user itself, or through deeply understanding a task, and this is where the domain-specific knowledge really comes in. So we'll see, and we are seeing a lot of that in the short term.
Okay. I get asked this question quite a lot, open source versus closed. I'm not going to ask you that, because when I get asked, I feel like it's a trick trading question. So I'm going to ask you, what needs to be true for open source to stand a chance and win against large closed source models?
Yeah, if you take this analogy of the kernel, right? This is it's not exactly the same as writing the Linux kernel, because here it's learned from data and all the code exists in, it's the rules are learned automatically from data, and the code exists in the weights and the activations. So it's funny, like it turns out that it took 15,000, the total of 15,000 programmers have actually worked on the Linux kernel, and you don't need, I mean, you're not going to need so many to train a model. I think the question is, where can people contribute the most, right? Where can people contribute the most? Data keeps coming up because it's such a unknown today that there's, and how can we select the right data to learn the right capabilities? There's also, we discussed about, people, there's open source interpreters that actually use closed source models and open source models, right? So I do think that there are several places where we can have large open source contributions. We don't quite have a manual yet. Somebody needs to write this manual, how to train an open source model, or how to build this community. And maybe with funding, government funding, this is actually possible. But I think that the contributions from most people will not necessarily come in just the training of the model, but in the other pockets.
Yeah, and like one thing that gets missed with open source is like today, there's no way to take that to the user. So there's kind of like learning from.
So the learning feedback loops, basically.
That it obviously does not. It's not that easy. But at the same time, to double on what Ashish was saying, like one thing that that is missing today is like we don't really understand the full capabilities of the model, right? Like Open Interpreter is like one way of like taking that further, and all the other projects that we've seen. And one thing that keeps coming up is like the need for better evaluations, because we're relying on like existing very handcrafted and not very general evaluations. So open source does have a chance in like bringing about standard methodology around like how to evaluate, what do you evaluate, getting a sense of like what are the differences in the capabilities of the model, and being able to extract out specific features from it, in training maybe smaller models that can serve on your phone. So there's a lot of room for innovation, but this kind of like end-to-end system does seem a bit harder with open source.
So now that we have this big reasoning engine, and which is going to keep getting better, and we're going to have different modalities of it, what is possible that we haven't thought was possible before, and how fast is it going to happen? Any ideas of examples of things that people would have thought as impossible and will happen now?
So when Rosenblatt actually built the perceptron, he said that this is a self-learning system that could learn anything. So even the origins of neural networks way back, actually people thought they could do everything, right? So we probably still think the same way about AI, but it's probably helpful. I think maybe what even I am surprised by is how quickly the rate is changing actually to accomplishing these tasks that we didn't think were possible. Now we think many things are possible, but it's how quickly we're getting close to it is actually the surprise.
So the impossible will happen faster.
Yeah.
All right. What personal problems would you like solved? Nikki?
Yeah, we were, for me personally, I think I'd be really, really excited if these systems can, break the barrier into like, being able to like really provide easy learning and easy access to education for everyone. That is one problem I know that a lot of people have tried in the past, and it's both, social and like, having the right technology itself. But today it seems that, we're closer to that than ever.
It's similar lines, actually. I'm excited. In my lifetime, I've seen one of the millennium problems being solved, the 10 millennium problems. And I think that we're now building these tools for thought that humans should, we should be very excited as a species that we're going to have these tools that are going to help us figure out the known unknowns and the unknown unknowns. And I would like to see some of the millennium problems solved in conjunction with AI and new AI models.
Okay. So a few things I took away. One is think super big, right? The other is keep building, don't stop. And actually, in the words of a great rock band, don't stop believing. Everything's about to change. Thank you.
Thank you.
A huge shout out and round of applause for our final speakers, Nikki, Ashish, and Ganesh. Thank you so much.